Hello friends, welcome to Dr. Ossai Physiology Academy, DOPA for short. This is the place where we make the learning of physiology easy, exciting, and effective. Thank you for joining me. And if you're new to this channel, you're especially welcome. And if you love the content that we share, kindly click the like button and also the subscribe button. And don't forget to turn on notifications so that I don't get to miss any new content that we drop. Now let's get started. So today we're going to be dealing with growth hormone. In fact, the name gives it off. The physiological action, growth. And so, but it's beyond just growth. So many other things. Okay, but now, remember, we've already laid a very good foundation from the introductory lectures and all of that, mechanism of action, classification of hormones. That's, in fact, discussing any hormone will just be a walkover. All right, so let's start. Now, growth hormone, first of all, is peptide hormone produced from the pituitary gland. That's easy to know because we've already studied the pituitary hormones. So now it's a peptide hormone produced from not just the pituitary gland but the somatotropes. Okay? A group of cells known as somatotropes. So this somatotrope now gives it a nickname. Not even nickname, the alternate name, which is somatotropin. Okay, that's the other name for growth hormone. Somatotrope. Anything soma means body, something that helps the body to grow, increase. Trop. It's about growth. Okay, so somatotropin. Now, growth hormone, when it is synthesized, it starts as an inactive hormone, as a pre-pro hormone or a pro hormone. Then it undergoes what we call post-translational modification, okay, in the Golgi apparatus, before it now becomes the active hormone. All right, so after it becomes the active hormone, it's now stored in secretory vesicles. These are the things you mention when discussing such a hormone. Because it's a peptide hormone, they are stored in secretory vesicles, and when they are stimulated from the hypothalamus, GRO, growth hormone releasing hormone, GHROH, it now uses exocytosis to secrete it. Okay? And being a peptide hormone, it is water soluble. So as we go, we're going to learn a lot of things. Very interesting. Do you know that growth hormone, some athletes abuse it? It's part of all those banned substances for athletes. When they do doping tests, they use it to enhance their performance. Why? I'm going to tell you that secret. Also, growth hormone, when it's excess, can also cause diabetes. Wow. Diabetes. I'm going to learn all that. So just stay with me. Now, the next thing is that growth hormone now has been released, secreted. Okay? It's water soluble. Now, the next thing is that it goes to bind to its receptor, which of course, because it's water soluble, it's located at the plasma membrane. Okay, water soluble hormones, they have their receptors at the plasma membrane. So among those mechanisms, it has the enzyme linked. It uses the enzyme linked mechanism. So the receptor there is an enzyme linked receptor. That's what growth hormone uses, the enzyme linked receptor mechanism, in the sense that that receptor has an intrinsic enzymatic activity. Okay, tyrosine kinase, called the tyrosine. Anything kinase has to do with phosphorylation. Okay, so we're now entering into the mechanism of action. Okay, so, but one interesting thing about growth hormone is that when it acts, it has two ways. It has an indirect mechanism and a direct mechanism. So let's get into it. So it activates this enzyme, which is part of the receptor, which now phosphorylates proteins within the cells. When they are phosphorylated, they are activated. Okay, and you know, activation of proteins lead to different functions. But now, let's go straight into the real physiological actions. Now, you have the direct mechanism which is affected by growth hormone itself. Okay? And you have the indirect, which is affected by a substance known as insulin-like growth factor 1. Okay? Look at it. Insulin-like growth factor 1. In short, IGF-1. Okay? This has another name known as somatomedin C. Somatomedin C. Right? So why does it do this? Now, when growth hormone is released, it goes to the liver. That's where most of this IGF-1 is produced. So it has an indirect. So the IGF-1 is the one that performs some of the effects of growth hormone, while sometimes it acts directly. Okay? So it goes to the liver, and then through the tyrosine kinase effect and all of that, it now phosphorylates proteins, and then it activates certain proteins known as through the JAK-STAT pathway. Now don't get confused. Don't get confused. Now, this tyrosine kinase phosphorylates some proteins known as Janus enzymes, Janus kinase, short JAK. Okay? There are a group of enzymes linked to this enzyme for growth hormone. Now, this Janus kinase now phosphorylates another set of proteins known as STAT. Okay? STAT. What does it mean? It means signal transducer and activator of transcription. Okay? So because growth hormone, it enables growth, and proteins being the structural and functional molecules of the cell, it doesn't just stop by activating proteins in the cytoplasm. It now goes inside DNA to activate protein. I know protein synthesis starts from transcription. So that's what it does. This one phosphorylates these STATs. These STATs, they are proteins. Okay? So it phosphorylates them and activates them. Signal transducer and activator of transcription. So this one goes, when they are activated by JAK, it go into the nucleus and activate genes there to start the process of protein synthesis, which starts from transcription. That's why it's called activator of transcription. Okay? And they now begin protein synthesis, and they now synthesize this IGF, insulin-like growth factor, that now goes and performs some very wonderful function that we're going to mention on the bone, linear growth, and the muscle. Okay? We're going to mention those two major effects: the effect on growth and then the metabolic effect as it relates to the direct and indirect mechanism. Alright? So don't go anywhere after this break. Right, you're welcome back. Now, let's start with the direct effect. We're talking about the physiological actions now of growth hormone. Okay? So the direct effect just has to do, it's talking about the fact that growth hormone now is the one that is acting directly. Okay? It's not using IGF, insulin-like growth factor. Okay? So the effect now, it has effect on protein metabolism, has the metabolic effect, has effect on fat metabolism and carbohydrates metabolism. And what does it do? Of course, it promotes protein synthesis. Now, you ask yourself, because adults don't grow, okay? But they need growth hormone, although in children, the levels of growth hormone is higher because they are growing a lot in size. But apart from that, proteins are needed for normal functioning. Okay, maybe you are going through stress and so on. You need proteins to help you keep up. So it enhances protein synthesis. And one of the ways that it does that, it makes it easy for amino acids to enter the cell. So it promotes uptake of amino acids. Right? Amino acids are the building blocks of proteins. So one of the ways it does that through all this mechanism is that it will activate receptors of that amino acid receptors, okay? So that there are now many in the cells, and then it promotes their uptake. That's how it enhances protein synthesis, and so on and so forth. Then for fats, it has a very interesting thing, is that growth hormone prefers the use of fats as a source of energy than glucose. Somehow like that. So it does what? It breaks down fats. You understand? So it promotes lipolysis. Lipolysis. It's a hormone of hunger and famine. So it breaks down fat, adipose tissue, and it now becomes glycerol and fatty acid, triglycerides becomes fatty acid, which now enter into certain reactions. You learn that in biochemistry, that now leads to the production of glucose. Okay, then for carbohydrate, they are linked. For carbohydrate mechanism, it inhibits the uptake and use of glucose. And one of the ways it does that is that the process of breaking this one down and converting it to glucose through gluconeogenesis and so on, acetyl-CoA, okay, is produced. So acetyl-CoA is the direct inhibitor of the uptake of carbohydrate. So that means of glucose. So that means it makes the blood glucose level to be high. You see that? That's why I said that when growth hormone is excess, when it's normal, it doesn't cause too much problem. But when growth hormone is excess, you have hyperglycemia, which is the main thing in diabetes. So it inhibits insulin action. Okay? So that's why I said it's diabetogenic. It can cause diabetes. Excess growth hormone. Because of this thing, it prefers use of fatty acids and so on to produce glucose rather than using glucose itself. Prevents the uptake of glucose. Okay? So the same thing, carbohydrate, we've talked about all of that. Direct effects, general this thing. So one of the significant things now, where it's related to why athletes abuse it, it's this indirect effect through IGF, insulin-like growth factor. It acts mainly on, produced from the liver, and then mainly in the muscle and bones. This is IGF act mainly in the muscle and bones. You know, when the muscles, when you are exercising, that's why you see people when they are gymming, you gym, the muscle will grow big. Growth. You see that? The muscle growing big, how does it do that? Through this insulin-like growth factor. It will go into the nucleus and activate protein synthesis, and not just protein synthesis, it will activate what? Cell division and differentiation. That's one of the growths. So as the cell, they are dividing, protein synthesis, amino acid coming, it's increasing in size and number. The division is making it increase in number, protein synthesis, raw materials being added, increasing in size. That's how you grow big muscles through exercise. So when muscles are exercising, they are more sensitive to growth hormone. Growth hormone is produced more, and it goes there to increase its size because there is increased workload. Okay, so that's how it happens in muscle. So that's why athletes, they abuse it when they take inject a lot of growth hormone to make their muscles stronger and bigger. Do you understand? Okay, then in bones, it promotes linear bone growth. You know, bones, let me draw a small bone here. Something like this. Something like this. Okay, so there's what we call the epiphyseal growth plate. Bones, they have two parts. You have the epiphysis. Epiphysis, that's here too, epiphysis. And here is the diaphysis. Okay, so in between this line here is where we call the epiphyseal growth plate. Why? Because that's where growth happens. So when growth happens in these places, the epiphyseal growth plates. There you have a lot of cartilage, what also known as chondrocytes. Okay, so what it does through insulin-like growth factor, it goes to those chondrocytes. They are cells, so chondrocytes, cartilage cells. And what does it do? It promotes proliferation. That means cell division. So they begin to multiply. And of course, multiplication and protein synthesis. They are increasing in number and increasing in size. They are growing. But apart from that, because if they are just multiplying alone, it will just be plenty of cartilage. So it's apart from proliferation, it also causes differentiation. Okay? So it causes differentiation of those chondrocytes. Differentiation is change of structure of form. Differentiation into bone cells, osteocytes, osteoblasts. So it converts the cartilage into bone. Do you understand? So it multiplies, increases, and then converts them into bone. So that's how the bone begins to elongate. Elongate, and so on. So that's how it causes linear bone growth, or your long bones. Okay? So that's how it happens. That's the effect on growth, and it uses this insulin-like growth factor. So now you ask yourself, how is growth hormone regulated? Very simple. You remember that growth hormone is one of those hormones that have connection with the hypothalamus. As a pituitary hormone, it is controlled, is stimulated to be released by growth hormone releasing hormone, which is from the hypothalamus. Okay? Then remember, the hypothalamus also has a growth hormone inhibiting hormone, which we said that the other name is called somatostatin. Static, that means it opposes growth. Okay, inhibiting hormone, the other name. Then another hormone that you need to know about is a hormone called ghrelin. This hormone is produced in the stomach, so it's related to appetite. Okay, this ghrelin, food intake, and all of that. So it's part of how it's controlled through ghrelin, the interplay of ghrelin, GHROH, GHIH. That's just basically what you need to know about growth hormone. Alright? So the next lecture, we're going to be talking about tyrosine. I know something tyrosine also is related to. That's why people who have low thyroid levels from childhood, they are short, dwarfs. Okay? So that reminds me of effects of overproduction and underproduction. I didn't want to mention because it's so straightforward. When growth hormone is excess from childhood, it causes gigantism. Grow into a giant. Okay? In fact, a very popular, world-known giant that lived. In fact, he's like the tallest recorded person in modern history. His name is Robert Wadlow. He was called the Giant of Illinois. He grew up to 8 feet 11 inches. From childhood, he had tumor of the somatotropes. Those somatotropes in the pituitary gland, a tumor. So secreting excess growth hormone. He grew very big. At age 5, he was as tall as an adult. Okay? But of course, because too much of everything is bad. He died young at age 22. Okay, so when it's absent, you have dwarfism. Okay, in the adult, when it's excess, it causes what you know as acromegaly. So the details are in the books. You read that up. A lot of features, growth of soft tissues. They have a very funny look. The jaw especially, and so on and so forth. Okay, acromegaly. Right? So that is basically what you need to know. The other details, you can get them in the text. So see you in the next video.